Joseph, I'm happy to welcome you with me on the stage. As you already heard, you can feel free to submit your questions at any time, and we will fit them right in the middle, anything you want to know. Joseph, you're the corporate VP of the Cloud AI platform at Microsoft. Before, you were corporate VP of the data platform at Microsoft, and prior to that, you were VP of the global inventory platform at Amazon.
Yes, thank you.
So, I'd like to start with a quote of yours, because you said, artificial intelligence is always dumb. Could you elaborate on that?
Yes. First of all, it's a great pleasure for me to be here talking to all of you developers as well. And I said artificial intelligence is dumb because it's really software. It's developers such as yourself who will be using software technology. AI is a new type of software technology and building new applications with it. And AI just provides the ability to learn from data. It learns from lots of data, develops models. And those models then have predictive abilities. And we have had, by the way, similar capabilities in the past. You know, physics, mathematics, that's all models. They're mathematical equations. The difference with AI models is that these models are learned from data. There is statistical learning, and these are statistical models. And they have statistical predictive power. And that's what AI brings. So I think it is, the word artificial intelligence makes it sound as though it is dramatically bigger than what it is. But at the end of the day, it is still software with statistical learning. And that's why I said AI is dumb. But it's a very powerful tool and a very useful tool.
Yeah, you already mentioned that when talking about AI, many people are thinking of the supercomputer with a consciousness, which can potentially threaten the whole world, which is a so-called deep AI, as I understand it. But it's much more realistic in the coming decades, at least, that we will mainly work with the so-called shallow AI, which will take over certain repetitive tasks. In other words, will the revolution of AI be much less spectacular than expected?
Well, I think it will be spectacular in very different ways from what we expect. Instead of artificial general intelligence, AGI, which is the deep AI, I think we will have artificial common intelligence or shallow intelligence, where you will be able to talk to everything, and it'll understand some things. You know, it's not reasoning in a depth, but you'll be able to have a great user interaction. So conversational interfaces will be very common. You will have systems for prediction, for forecasting, identifying fraud better, quality control. Every machine will work better. So there will be a little bit of AI in everything that we use, including your smartphone will have AI, your messenger, your conversational interface will have AI. So AI just becomes very useful. It creates lots of new experiences. Those new experiences will be very interesting and very different. Just like, you know, when electricity was invented, lots of electric machines came. But it was not entirely obvious that there was a dramatic change, right? If you take a look over the 20th century when electricity was introduced, well, lots of things became better, but electricity was hidden behind the scenes. In some ways, it'll be like that.
Okay, so more invisible change.
It's more invisible, and vast amount of AI in the world will be invisible AI.
Okay. Google, Apple, Amazon, and also Microsoft, of course, are heavily investing into AI research now. Does it mean that the future of this technology will be decided amongst these giant companies?
I don't think so. I think the world is of AI development, a lot of it is happening in open source. Tremendous amount of open source innovation. And many of the fundamental advancements in deep learning, which triggered the latest AI revolution, came from the universities. As I go to AI conferences, I see an incredibly healthy amount of creativity happening. I think the cloud is enabling AI or computing capabilities to everyone who wants to use AI. I think there is increasingly significant amount of valuable data that's accessible to developers to develop AI. And also platform companies like Microsoft are giving tools on the cloud and making access to AI development tools so much more democratized that a lot of development of applications is happening on those platforms, and that's also democratizing it.
Could you explain what you're doing differently at Microsoft than, say, for example, Google or Amazon, who are mainly or largely concentrating on speech recognition and assistance, voice assistance?
Well, so Microsoft is a platform company. We have a great cloud. We have one of the most widely deployed clouds in the world with the most coverage across the world. So we are bringing cloud and AI together. And we are creating a great platform on the cloud with a very big breadth of pre-built AI capabilities. So you can build applications very easily as a developer. It can be language understanding. We, for example, provide Bing Search API. We are the only company that provides a full internet search engine at your fingertips to integrate into your software applications through an API. We have translation, we have language understanding, we have bot service for conversational AI. So a very good breadth. And then we also make many of these AI capabilities customizable. We also bring the power of the hardware capabilities that are in Azure to build AI as services. And then we integrate that with data. And so we provide a full platform with a lot of comprehensiveness to developers.
So you would say that AI can be democratic and used by all people and not just the lucky few who have the knowledge and therefore the power?
That is correct. In fact, in the past, if you look at it, the only companies that were able to use AI effectively was companies with very large talent base, very large companies with lots of data and with the ability to hire data scientists and machine learning people and build AI applications custom and develop a competitive advantage. What has changed now is that with the power of the cloud, these AI tools are available to everyone, the compute is available to everyone, and you're able to, as software developers, build these applications and develop hosted software as a service applications on the cloud. And that democratizes access unlike any time before.
You said something interesting in this regard. You said that you don't have to really know how this AI which you're providing at your platform is working in order to use it. It's just there, you can take it and you don't have to be an expert.
Right, that's correct. So for example, in my keynote today, I showed an app called Helpicto, developed by a French ISV called Equidex. This is an application that allows mothers to communicate with autistic children. And it uses speech recognition. So the mother says what she wants to communicate. It calls a speech API. It recognizes what the mother said. Then it understands the key terms in that transcription, then picks the right pictures that match those keywords and shows the pictures on the phone so the mother can show the pictures of the things she's speaking to the child as well. And this results in a much better communication. And that entire app was built by a software developer who was not deeply an expert in AI at all. He used the speech, entity extraction, image understanding, and all of these APIs from the cloud and connected them together and created a mobile application using Xamarin. And all of this took only a few weeks. And this is the power that's available. With, now there are 35 different advanced AI APIs available on the cloud. It's all hosted. So all of you as developers, when you build an app, can infuse those AI APIs into your application and get a power of AI.
But if you have something like an AI, which you can use, but you haven't really understood the technology behind it, how it works, can't this be a bit dangerous because you don't know with which powers you are dealing, and isn't that sort of a gap between the knowledge and the usage?
Yeah.
Like with what you don't know what happens to your data with all the social networks?
It's a good question. I think there has to be a certain code of conduct around how AI is used. But let me also tell you, it is like software. Now, you as software developers use lots of sophisticated frameworks and functions and software libraries all the time. How much do we know about those software libraries and how exactly they work? They have a specific function, but we can test it. We have a debugging process. And the same concepts apply to AI as well. When you build an AI application, if you build the right testing framework around it, you can verify that it works as advertised. You can test it with the kind of data that it will see in deployment. And if you follow the process of high-quality, rigorous software development and testing, along with, with AI, I think you can get a reliable app.
You've also compared AI to the paradigm shift that came with the internet. And if we think back to this time, I mean, it was a huge opportunity, and there were many people who were smart enough to recognize this and to do something with it early, and those people are now very successful and also very rich. So I'd like to know, how can startups and companies take advantage of this point where we are at a certain threshold before the big AI revolution?
I think this is a fantastic question. Startups have incredible opportunities, especially if they start reimagining the world with AI. When you think AI first, you think about software in a different way. It was the same when software world started also. People at that time were thinking hardware first, meaning electronics first, right? Software came after the electronics revolution. Where people at the time were very familiar with electronics when PC started coming in. People would think about circuit boards and creating circuits for various applications, and that was how you were thinking. People were not thinking software first at the time. People were not thinking about electronics being, hey, here's a microcontroller that I could program, and that could do all the tasks of a complex circuit without you actually building and designing a circuit. And it changed the game when microcontrollers and everything became programmable, and then operating systems came on top of it, and operating systems changed the game in computing. There's a similar kind of transition with AI and traditional software. You start thinking AI first about getting some task done, right? And doing so intelligently. Then you have a different frame of mind about how you develop the application. I think that kind of shift is where companies will start taking new advantage. Now, if you were to think about it in a more subservient way, which is there's a software application, and I maybe put some AI here, a little bit of AI there, well, then you're really not making a revolutionary change. I think that's the difference you have to think about.
So you would say that the first thing you have to do is you would have to ask yourself, what's the problem that I want to change, and how can I achieve this with AI?
Right, and at the end of the day, it's your imagination that makes a difference, right? We are so fond of thinking about algorithms and technology and so on, but it is the developer's creativity and your imagination that makes a difference.
So if a young developer would approach you and ask you for advice and would say, can you tell me which area of AI will be especially attractive in the future, what would you say?
Well, I can say in terms of human impact. For example, I believe healthcare will be revolutionized with AI. It is possible now to predict chronic disease conditions, emergencies, risk of readmission in a hospital after you've been treated. You optimize a hospital workflow dramatically better, do eye care better with AI, so on. Every aspect of healthcare is going to be made better with the power of AI. And I think that's going to touch the 7 billion people on the planet. That's going to be one very powerful area. Now, economic opportunity in that, you will have to find the right areas for economic opportunity. But as the world's population ages and the need for care becomes very important, and critical care, and also preventive care, and there are areas where AI and healthcare come together to make revolutionary differences in people's lives.
And what is the biggest mistake you can make now when you enter the field of AI?
Well, I think ignoring AI.
Okay.
Right. I think you should really be entrepreneurial about taking any of these technologies and learning how it actually can be applied and starting to imagine new things. By the way, you should all feel free to ask questions as well on your app, and we'll be happy to take some questions if there is time.
There has nothing been on the screen so far. Okay. So you said that AI should be useful. Which areas aren't useful? Are there areas where you would say it's not worth investing something to create AI in this area because it's not of any help?
Well, there are many areas where traditional mathematics and engineering work extremely well. So when you're constructing buildings or bridges or most of those, physics, mathematics, engineering has very effectively tackled many of those problems. There is not as much need for statistical models. And that's not the area where you're going to apply AI. You're going to apply AI where there is tremendous amount of data, there is an opportunity to learn, there's human interaction, there is opportunity to revolutionize a process, a business process. Those are examples of areas where you want to apply AI.
Okay. So let's take a question from the audience. In what way will developers that are not familiar with the concepts of AI and ML be forced to adapt and use these technologies in the future?
Well, developers will start using these pre-canned APIs, so conversational interfaces, for example. I think a lot of software applications will naturally become much more friendly, and you will start having interactive conversations with it. People will sort of expect it. People will expect, instead of having complex menu-driven conversations in an app, interactions in an app, why don't I just ask it a question and it actually knows what to do and get me to that? And so that might be an example of an area where in many consumer apps, people will naturally expect you'll have a conversational interface, or that you'll be able to interact with many services over chat. I think that'll be a natural thing. So because chat has become such a big part of our daily life, even in communication, so then you start expecting through chat, why can't I get certain things done? So those are examples of areas where you might find it important.
And you have to help me with this question because I have the same. What do ML, AI, DL, and AR terms mean?
What are similarities
What
and
are
differences?
Similarities and what are differences?
Yeah, this is a great question. So ML stands for machine learning, AI, artificial intelligence, DL, deep learning, AR, augmented reality. So let me explain the differences. So really, the advances in AI in the last decade have come from a much more precise term called machine learning. It is a very rigorous concept in computer science. It's about the ability to learn from data. And if you look at, for example, the latest generation of translation, translation services today are built with neural machine translation. Neural machine translation learns from data. So if you have English and Chinese texts that are translated, you look at vast amounts of that data, and it learns a way to translate from English to Chinese or vice versa. In the past, these applications used to be built with rules and grammar and a traditional computational language technique. And it was enormous amounts of code. In fact, translation systems used to have 1 million lines of complex, very, very complex code, and it was very hard to build. And when neural machine translation came, it became something like 500 to 1,000 lines of code using neural networks. And so that is what changed AI. And most of the AI you see today depends upon machine learning. AI, however, is a broader term. People include more than learning. People include planning. People include optimization. People include much more of the traditional rule-based systems, and that combined with machine learning. And it's also a more popular term, right? And more general, in many ways more fluffy, in my opinion. Deep learning is specifically neural networks. In the beginning, when neural networks came, at the time when I did my PhD back in the early 90s, they were what are called shallow networks. They were 3-layer neural networks that could learn only limited things. And in the last decade, it became possible to have neural networks with tens, maybe even hundreds of layers. And it was possible to make those networks work. And that changed the accuracy of machine learning. That's what deep learning is. And finally, AR, augmented reality, is about really connecting what you see in, say, a HoloLens or a virtual reality thing with both reality and interpretation of reality and knowledge from the internet infused into that reality. So it's augmenting, enriching that reality, or making mixed reality happen.
And a question that seems to be fitting in this context, what are the required technologies and programming languages needed to dive into AI or ML?
Yeah, great question. You know, these days Python has become the most popular language. You know, people are using Python to do all the development and testing. And when they deploy, then the models are invoked from your language of choice, whether it be C#, .NET, you know, or Java. You will call those models. But when you're actually developing the machine learning systems, Python has become very popular. People, when they go to big data, they're starting to use Spark a fair amount along with these. So that would be the. And then for much more traditional statistics and much more of the analysis of data and data science, people are using R quite a bit.
And another thing the audience would like to know, how is it possible for an AGI to be invented during this century? And what companies are currently interested in the creation of strong AI?
Yeah, that's a great question. You know, I am honestly a little skeptical of AGI. Here is why. We don't even understand to a first order of understanding how our brain thinks and works and has consciousness. This is very different from every other scientific field. We know biology. We know how genetics work. We know how cells work. We know everything to a first order of understanding about how the human body works. But we don't know how consciousness works. We don't know how we reason. We don't know how we think, even to a first order of understanding. We know neurons. When we don't even have that first order of understanding about our own brain, how likely is that by random experimentation you will get artificial general intelligence? I just don't understand how that will happen, honestly. So that is why I'm a skeptic of AGI. But AI might become very, very useful. You may have lots of software that feels very intelligent, but it is still software, right? And that's where I think it will be.
How will AI change user experience and interfaces? Like, for example, will we be using a smartphone in a few years, or will it be just?
I think this is great. Redundant? I think the combination of the smartphone-like technologies. Smartphones are great. First of all, because it has got enormous number of sensors. It's got great computing on it. It is independently powered with a battery. It has communication, right? Wi-Fi and data communication to the cloud and cloud services. That's fantastic. What I suspect will happen in the future is the smartphone itself will get disaggregated. It won't be necessarily one combined device. You might have a smartphone that pieces of it are all over your body. I mean, it's a wearable computing. I think the main thing will be how do you power each of these independent pieces. I think when we are going to solve the power problem, maybe charging it from ambient signals. There are already efforts to charge from Wi-Fi signals. There's also remote charging possible. I mean, you already have the ability to charge a smartphone from an inductive way by just putting it on a charging pad. When that kind of capability comes, there might be many more smaller devices that you might have that might all be able to communicate together and communicate to the cloud services that you need, and it provides functionality. I mean, to some extent, you're already seeing that with a smartwatch and a phone. So now you have two devices instead of one single one, and that helps in some way, and each has its own special function. I suspect intelligence will be put, a little bit of intelligence will be put into each of these. There'll be a little bit of intelligence here, into the phone, into things around you. There'll be ambient intelligence, and that will be the future.
But if you think about it, people still seem to be a bit reluctant to wear something obvious like glasses, like Google glasses. I mean, you look funny.
It has to be natural, right? It has to be natural, or it has to be hidden. I think that user interface innovation and design will happen, and that's when it becomes so much more easy to do. And so, for example, when I step on the stage, I may not have to clip on a new microphone. It may be that maybe my smartphone can actually pick up the signal, or there might be another device that can pick up all of these, and I can still talk to you just naturally, except now it comes through the room audio, and those kind of connections can happen.
And what about implants or something, you know, these scenarios from horror
Those are more
movies.
sci-fi, honestly, right? And, you know, I don't know whether it's implants or tattoos, but I think it will be something we are comfortable with. And that's where the real innovation has to come, not just from software developers, but from overall. And I think we'll be comfortable with whatever comes. Otherwise, you know, what's great about our economy is we don't adopt things unless they are good for us. So
yeah,
we have a
true.
natural selection process.
Another question from the audience. How do you verify that your AI works, as it is a really moving target?
Yeah, it's a great question as well. I think, you know, we will develop new debugging processes for AI, testing processes. Software world has developed great testing methodologies. You know, one analogy I make, think about pharmaceutical development, drugs, right? Healthcare and drugs. You know, pharmaceutical companies put drugs that are initial candidates through a very rigorous testing and development process, and there are things like randomized clinical trials that compare, you know, a randomized trial in a control sample with a treatment sample and see the differences. We will come up with similar ways of testing AI. And that's how we will develop confidence in AI, that especially AI that is deployed in mission-critical environments. And I think that's how you develop trust in whether it works.
And another question from the audience. Where is the borderline between elaborate algorithm and artificial intelligence?
That's a good question. I think you start drawing the borderline when the system is able to learn and adapt. If an AI algorithm can learn from data, can improve its performance, can adapt to its circumstances, I think then it starts becoming AI.
Okay, so a clear distinction between those two.
Correct. Learning and adaptation, I think that's what distinguishes it. Now, there was another really interesting graphic that I saw some time ago. If you think about traditional programming, look, you have data as an input, you have a program that somebody wrote to process that data, and it produces an output, right? So data, program, output. Now, AI changes it in a little bit of a different way. Think of the learning phase having data as an input and the output that you want it to have, okay, as an input also. And AI learns and produces a representation of a program, okay? So the output of that is a program. So data, the desired output, and then you get a program as an output, and then you run that quote-unquote program. This is a neural model that you have, and that's the one that actually is in your software application. So that's one of the differences.
Okay. There's a question that I also have on my list. Will AI reduce the availability of jobs for a part of our society?
Yeah. This is a controversial topic, obviously, but I think you can ask that question about every technology that has come in the past. I know there were a lot of fears 30 years ago, 40 years ago, about computers. And we had exactly the same arguments, that computers will replace jobs, that computers will change the society drastically. What it instead did was, it created tremendous amount of efficiency in the economy, made it possible for the economy to produce far more goods and services at a much cheaper price. And it created new classes of jobs. And as a result, we actually have a dramatically more efficient economy, dramatically more access to healthcare, dramatically more access to information, dramatically more learning opportunities. We create new jobs. I think what happens whenever new technology like this comes is we stand on the shoulders of that. And humanity, we have a natural instinct to use these things to our economic advantage and create new economic systems and new technologies, provided we have great governments, right? I think the most important thing we all need as a society is a democratic system that creates great governments and administration and appropriate regulation so that human creativity can flourish and can use all of these technologies, everybody has access to the learning required to use these technologies, and they can build greater systems on top of it.
Okay, but won't there be at least a certain time when the old jobs are becoming redundant, but there aren't the new ones, or at least the people aren't educated to perform the new ones? Because when you look back at how the computer changed the economy, there were at least some people who just then were too old to learn something totally new, or their whole field of expertise was just not needed anymore.
Constant change is always there, right? And that is, again, equally true about all the technologies of the past. Most of the jobs that are in the economy today did not exist 100 years ago, at least not in the same form. But what has happened in that time frame is we all have become dramatically richer. In fact, I was looking at a percentage of people who live in poverty in the world today. It is amazing how much it has changed from 1965 to today. The percentage of people living in extreme poverty is dramatically shrunk. We wouldn't have expected that. And the access to healthcare, the longevity, the number of years people live now has dramatically expanded. And I think these are unseen benefits that are happening very broadly that people lose sight of because you're not counting these numbers. You're not statistically looking at it. Instead, you're seeing sensational point things in the media, and that we generalize from.
Okay, so you see a certain tendency at the media companies to just exaggerate the threat or the problems.
Correct, and we are far more risk averse, right? And so we hear about a potential risk and we pay significant attention to it. Humans are naturally risk averse, but we don't see the statistics of the progress that is happening in the world today. And as a result, we don't know how much progress has actually happened, which is very interesting.
Yeah. Another thing the audience wants to know is, what is your take on the evolution of AI, ML, VR, AR, and the consequences of this in the next decade or so?
Well, in the talk that our CEO gave at the Build conference 2 weeks ago, he showed an amazing picture. He showed a picture of New York before electricity and internal combustion engines, then showed a picture in the 1930s or 1940s afterward. And the thing is, what you saw was, you saw now cars on the road, you saw very good tall buildings, but there was no evidence of the technology that powered it. There was no visible electricity. You can't see electricity. Nobody can see an internal combustion engine. You don't see oil being used, gasoline. You don't see any of this. What will happen with all of these technologies like AI and software is they will be invisible. They will be behind the scenes. We won't be able to really see the power of the technology except things around us improve. We have new experiences. We have much more safer mass transit maybe. When cars have AI to assist driving, well, roads become safer. When there is AI being used inside hospitals to save lives, people's healthcare becomes just so much better. You have much less accidental deaths. You have people living longer, healthier, and happier. And you don't necessarily see the impact of it, but you realize the benefits. And then economy itself becomes more efficient. Things become cheaper. Now, people may be worried about deflation, but what's happening is today, if you look at what you consume, a lot of experience you consume are software on your phones, and you get a lot of it for free, and it's cheaper. A lot more of what we experience and provide joy to us as human beings may just be significantly cheaper and more efficient. So I think we will lead fuller lives with more efficiency in the world, maybe even save the planet in many ways, because what happens in the world today, there is tremendous amount of waste and pollution that is creation of the older revolution of technology. The more efficient, and AI and data science and everything, in fact, it's one of the few technologies that I've realized actually brings more efficiency to the economy. That actually is helpful. Perhaps we will actually be able to better, help the planet, lead better high-quality lives, have better insight into what governs our lives and our planet. That will improve our lives.
Okay, so the changes will be much more subtle and not like if we look 10 years into the future, it's not like in Back to the Future where you see all these changes and all these futuristic technologies, and so we don't have to change our behavior that much. We will live like today, only more efficient.
Exactly, and if we have the right governments especially, that is very important, right? Now, even if you think about societal problems or important problems like global warming, because of the power of computing and the cloud and the ability to statistically collect vast amounts of data and analyze things, we have so much more insight into our planet and its changes. And that is power that computing and data and algorithms and science brings about. Therefore, we can understand the forces that control us as a planet, and we can try to work and improve it and come up with the right laws and regulations and so on. And AI should be thought of in the same context.
Okay, there's a question related to Microsoft. How does Cortana leverage Microsoft's AI technology?
Great question. So Cortana speech recognition is entirely built on the state-of-the-art speech our Microsoft research innovated upon. Its language understanding, its ability to interact with the calendar and email and be able to create a more productive environment. So these are all examples of how Cortana uses Microsoft technology and builds on top of it to create a more useful assistant, especially in your day-to-day working life. That's where it makes a huge difference.
You've mentioned that, especially in healthcare, AI is going to make a huge difference. And there's a little bit skeptical question about that from the audience. With all those data that is getting collected, often sensitive and personal data that's needed for healthcare, how do we know which AI company to trust with it?
Yeah, you know, around personal data and healthcare, Europe has been leading in terms of regulation and privacy. And I think the use of that data is supported only in specific circumstances. And I think it is that kind of government, far-sighted government administration, that is the key. It is not a fear of AI, right? And when you're using healthcare data, such as electronic medical records, to improve human condition by predicting things. Now, for example, we have a partner called Epic. Epic has built a cognitive computing platform on Azure. And Epic has about coverage of 65% of the US population's electronic medical records. But it's not Epic that is holding the data, it's the hospitals that hold the data in Epic software systems. And Epic is providing computing capabilities to that software that incorporates AI that allows those hospitals to build very effective predictive systems. For example, they're able to predict hypertension, high blood pressure, up to 2 years in advance from electronic medical record data. And when you know that in that far in advance, you can take steps to prevent hypertension and its negative effects. There are similar opportunities to improve the workflow in a hospital. You know, people have found, for example, one of our other partners is a company called Kensai, and they build lots of machine learning models to help hospitals improve care. And they found, for example, when patients get tired of waiting in a hospital waiting room and certain kinds of patients leave, it can be bad because they might have a serious healthcare condition that comes back in a much worse form later. And so they've built a model to predict what kind of patients are at risk of leaving and what kind of conditions from electronic medical record data they should be aware of so that you pay attention to those people who are at risk of leaving and get them treated, because letting them leave without being seen is high risk. And so that improves patient care, and so on. So these are all examples where healthcare can be very, very effectively improved with AI.
I mean, you can't argue with that why this would be beneficial, but is there any way to prevent something like Cambridge Analytica happening in this sector with healthcare data? If I remember correctly, I've read something about Mark Zuckerberg wanting to cooperate with hospitals. Yeah.
Well, I think healthcare has always been a lot more controlled and regulated environment. In fact, in many ways, there is too much regulation that prevents access to life-saving technologies like AI. In fact, in many hospitals all over the world, if you think about it, hospital errors and problems of how hospital is run is actually one of the largest causes of adverse effects to patients. There are lots of areas where these things can be improved. In fact, in many ways, government should ask that data be used effectively. Now, I'll give you one example. Does anybody here know who the first female data scientist was? Anybody? It's a very famous name out of Europe. Florence Nightingale, exactly. Florence Nightingale was inducted to the Royal Statistical Society for her contributions to applying statistics to hospital data and healthcare data. And one of the first things that she did was to show that during the Crimean War, more people died in hospitals of hospital infections than people who died in the battlefield in war. And that changed hospital care dramatically because the improvement in hygiene that her studies did made a huge difference in the quality of care in hospitals. So it was a use of that kind of data that dramatically improved healthcare. And I think it almost is a right that we should be, as governments, demanding that all these systems use population data and internal operating data to improve healthcare.
Sadly, we have run out of time, but thank you very much for this fascinating discussion, and also thank you and your audience for all those interesting questions. And yeah, thanks for your attention. And
thank you very much. It's been a pleasure.